You lie still and the world feels quiet. The floor beneath you feels solid, unmoving, reliable. It holds your weight without complaint, as it has held countless others before you. Buildings stand, roads stretch, mountains rise, and everything appears settled, as if the earth has finished all its important work long ago. In the calm of this moment, it is easy to believe that nothing below you is changing. But beneath this quiet surface, the planet is never truly still. Far below your body, far below the deepest roots of trees and the slow pathways of groundwater, heat moves. It does not rush. It does not hurry. It drifts patiently, the way warmth spreads through a room long after a fire has been lit. This heat is ancient, older than oceans, older than life itself. It is leftover energy from the Earth's formation, trapped deep inside, still finding slow ways to escape. You are resting on a living planet, not living in the way animals move or plants grow toward the sun, but living in a deeper sense, a planet that circulates energy, that reshapes itself over immense spans of time, that remembers its past in layers of stone. The ground beneath you is not just rock. It is history, compressed and folded, warmed and stretched, breathing in cycles too slow for human notice. As you breathe in and out, the Earth does the same, though its breaths take thousands, sometimes millions of years. The outer skin of the planet, called the crust, feels thin when imagined this way. Like the surface of a lake seen from above, it looks calm, but beneath it, currents move. Huge slabs of crust, called tectonic plates, drift across the planet's surface at speeds no faster than your fingernails grow. They collide, pull apart, and slide past one another, reshaping continents without sound. You never feel this movement directly. That is part of what makes it so easy to forget. Yet this slow motion is constant. Where plates meet, pressure builds. Where they separate, heat rises. Melted rock magma forms deep underground, not as rivers or pools, but as thick, glowing material trapped within the planet's body. It waits there, heavy and hot, held in place by layers of stone above it. This is not chaos. It is balance. The Earth has been managing this internal heat for over 4 billion years. Too much release, and the surface would be violent beyond recovery. Too little, and the planet would cool into stillness, its internal motion frozen forever. Instead, the Earth releases its heat slowly, through cracks, ridges, and volcanoes, gentle leaks in a vast, pressurized system. Volcanoes are often imagined as dramatic mountains, exploding and roaring. But most of the planet's volcanic activity happens quietly, far beneath oceans, along long seams where plates drift apart. There, magma rises, cools, and hardens, building new crust grain by grain. This is how the ocean floor renews itself, silently, endlessly. Even now, as you rest, this process continues. You may imagine the Earth as a finished thing, complete and settled. But in truth, it is always becoming. Mountains rise and erode. Seas open and close. Continents wander. What feels permanent to you is temporary to the planet, a momentary shape held for a while before changing again. The ground beneath your feet has traveled. The land you know may once have been seabed, covered in water and drifting life. It may once have been closer to the equator, warmer, wetter, or buried beneath ice. These changes did not come suddenly. They unfolded slowly, with patience, with inevitability, guided by forces that never sleep. This is the Earth's deep rhythm. And deep within that rhythm lies heat, persistent, restless, powerful. Heat that can soften rock, drive motion, and, at rare moments, escape in astonishing ways. But for now, it remains contained, moving gently through the planet's interior, like warmth beneath a thick blanket. You are safe on the surface, cradled by layers of stone that have learned how to hold this energy. The crust bends without breaking most of the time. Pressure accumulates gradually. Release, when it comes, is often subtle. A distant earthquake, a slow uplift of land, a gentle outpouring of lava far from human eyes. The Earth is not waiting to erupt. It is simply being what it has always been. When you imagine the planet this way, fear softens into understanding. Volcanoes? Earthquakes and shifting land are not signs of instability. They are signs of life, of movement, of a system that has not gone silent. A completely still planet would be a dead one. The warmth beneath you is the same warmth that once shaped the earliest continents. It helped separate Earth from a frozen, airless world. It powered the cycles that allowed oceans to form and remain liquid. It created environments where life could begin, sheltered and fed by chemical energy rising from below. Even your own existence traces back to this internal fire. The minerals in your bones, the metals in your blood, were forged in stars long before Earth existed, but they were rearranged here by heat and pressure into the forms life could use. The planet's slow churn made the surface diverse, rich, and habitable. As you lie quietly, you can imagine this heat as a presence, not threatening, not urgent, but enduring. A reminder that beneath stillness, there is motion. Beneath silence, there is sound too deep to hear. Beneath rest, there is work continuing faithfully. The Earth does not rush its changes. Neither do you need to rush your thoughts. You can let your mind settle into the same pace as the planet, slow, deliberate, steady. With each breath, you become more aware of the layers beneath you, stacked not just in space, but in time. Each layer holds memories of ancient climates, vanished seas, forgotten skies, and deeper still, beyond memory, lies the heat that drives it all. As sleep begins to soften your awareness, you may wonder how this hidden fire once shaped the world before humans ever watched the sky. When eruptions left no stories, only scars written into stone, waiting to be read. You drift backward in time, far beyond memory, beyond language, beyond the first human gaze lifted toward the sky. There are no names here yet, no borders, no calendars, no stories spoken aloud. The planet exists without witnesses, shaping itself patiently, the way breath moves in a sleeping body. The land looks unfamiliar. Continents are smaller, rougher, still learning their shapes. Oceans spread wider and warmer, their edges unfinished. The sky carries no birds, no smoke from fires made by hands. Only clouds, wind, and light move above a surface still deciding what it will become. Deep below this young surface, the Earth's heat presses upward. There are eruptions in this world, but no one sees them. No one records their timing or fears their arrival. When magma breaks through the crust, it does so into emptiness, pouring out into open air or shallow seas. Lava spreads slowly, glowing red and orange, then darkening as it cools, forming new land where there was none before. Ash rises into the sky, fine and pale, drifting for days, weeks, sometimes longer. It settles gently across vast distances, like gray snow falling on stone and water alike. No footsteps disturb it. No voices react. It simply falls, layer upon layer, a quiet blanket marking time. This is fire before history learns to speak. Each eruption reshapes the planet, not dramatically all at once, but steadily, persistently. Lava hardens into basalt. Ash compacts into rock. Gases released into the air alter the chemistry of the atmosphere, thickening it, warming it, preparing it to hold oceans and, eventually, life. These early eruptions are not disasters. They are construction. The Earth is building itself piece by piece, using heat as its tool. Volcanoes act like release valves, allowing energy from the planet's interior to escape without tearing the surface apart. They create land, recycle materials, and redistribute elements essential for future ecosystems. You can imagine these processes unfolding in deep quiet. There is no sudden panic, no urgency. Time stretches wide here. An eruption that lasts months or years is brief in the planet's perspective. Cooling lava flows become foundations that will endure for hundreds of millions of years. Even silence has weight in this era. Without life to soften the land, erosion works differently. Rain falls on bare rock, carving channels slowly. Wind shapes surfaces without resistance. Oceans lap against fresh stone, dissolving minerals and carrying them away, feeding chemical cycles that will one day support living cells. Volcanic gases rise into the sky, carbon dioxide, water vapor, sulfur compounds. They linger, reacting with sunlight, helping regulate temperature. Without these emissions, Earth might have frozen long ago, locked beneath ice like some of its neighboring worlds. Fire makes the planet gentle enough for water to stay. Again and again, eruptions reset the surface. Older layers are buried. New ones are formed. Landscapes appear, vanish, and reappear in altered forms. The planet is not searching for permanence. It is experimenting, testing balance, adjusting itself slowly. You sense how creation and destruction are not opposites here. They move together, inseparable. Each flow of lava erases something and creates something else. Each ashfall ends one surface and begins another. Loss and formation share the same motion. There is no intention behind it, no plan. And yet, patterns emerge. Over time, these volcanic cycles stabilize the planet. The crust thickens. Continents grow stronger. Oceans deepen. The atmosphere settles into a range that allows liquid water to persist. These conditions are rare, fragile, and sustained only through constant adjustment. Fire is the quiet caretaker. As millions of years pass, life begins its earliest experiments. Simple organisms appear in the oceans, feeding on chemical energy released from the planet's interior. Hydrothermal vents, volcanic openings beneath the sea, provide warmth and nutrients, sheltered from harsh surface conditions. Even here, volcanoes are not enemies. They are providers. The ash that once fell on empty stone now feeds microscopic life. Minerals released from volcanic rock dissolve into seawater, becoming part of biological processes. Iron, phosphorus, sulfur, elements essential for life, circulate through the planet because fire brought them to the surface. You are connected to this ancient exchange. The atoms in your body have passed through eruptions like these. They have been melted, cooled, broken apart, and reassembled countless times. Before they became part of you, they were part of lava flows, ash clouds, ocean sediments. This deep past does not rush. It unfolds like a slow breath held over eons. Volcanoes continue to erupt, sometimes gently, sometimes with greater force. Some events are large enough to darken skies temporarily, cooling the surface for years or decades. Life responds by adapting, migrating, or waiting. Extinction and survival weave together, guided by conditions shaped in part by volcanic fire. Still, no one is watching. The planet records everything, but it does not announce its changes. Layers accumulate quietly, preserving chemical signatures, trapped bubbles of ancient air, mineral crystals frozen at the moment of their formation. These are the planet's memories, written without words. You float through the silent archive, sensing how much has happened without being observed. The Earth does not need witnesses to become what it is. It reshapes itself regardless of attention, guided by forces older than awareness. Eventually, much later, creatures will emerge who look at volcanoes with fear and wonder. They will name them, mythologize them, study them. But for now, fire works alone, unjudged, unremembered by minds. And as you rest, letting this deep time settle around you, you may begin to wonder how some of these hidden fires grow so immense, so patient, that they reshape not just landscapes, but entire climates, becoming something far larger than an ordinary volcano, waiting quietly beneath the crust. You remain in deep time, but the focus narrows. The Earth is still quiet on the surface, still unhurried, still offering no warning. Yet far below, something different is taking shape. Not louder, not faster, just larger, deeper, and more patient. You are learning that not all volcanoes are alike. Most volcanoes are expressions, narrow pathways where magma rises, releases pressure, and cools. They form cones and mountains, shapes you can see and name. Their eruptions may be dramatic, but they are localized. A valley changes. A skyline shifts. Life adapts nearby. A supervolcano is something else entirely. It does not announce itself with a peak. It does not rise proudly above the land. Often, it hides beneath plains, forests, or lakes. From above, it looks calm, unremarkable, almost ordinary. Yet beneath that calm surface lies a vast chamber of molten rock, so large that it reshapes the rules of eruption itself. you begin to understand that super does not mean explosive in personality. It means immense in scale. Deep below the crust, magma collects slowly. It is not liquid like water, but thick, heavy, resisting movement. It carries dissolved gases, water vapor, carbon dioxide, sulfur, trapped under enormous pressure. Over time, more magma arrives, injected from deeper parts of the mantle, adding heat, volume, and tension. Nothing releases yet. The surrounding rock bends slightly, absorbing stress. Minerals shift, cracks form, then seal again. The system adjusts, always seeking balance. This process can take hundreds of thousands of years, sometimes more. A supervolcano does not rush. It waits. You can imagine pressure building the way a thought forms just before sleep. Not sudden, not sharp, but gathering. With ordinary volcanoes, pressure escapes relatively often. Small eruptions relieve the system, but with a supervolcano, the magma chamber grows too wide, too thick, too insulated. The crust above becomes strong enough to hold it in place, sealing the energy inside. This containment changes everything. As gases remain trapped, pressure increases. The magma becomes richer in silica, making it even more viscous, more resistant to flow. Heat lingers. Stress accumulates. The chamber expands, pushing upward, subtly lifting the surface above it. From the outside, nothing seems wrong. Rivers flow. Grass grows. Animals pass over ground that is quietly rising millimeter by millimeter over centuries. Lakes form where the land sags slightly at the edges of the chamber. Steam escapes through cracks in gentle whispers, carrying heat away without revealing its source. The planet appears calm. But calm is not the same as empty. A supervolcano is not a mountain waiting to explode. It is a system waiting to fail. Failure comes not from anger, but from excess. When pressure exceeds the strength of the rock above, fractures propagate rapidly. Gases expand violently. Magma fragments into ash. Instead of flowing, it erupts as clouds, racing outward at unimaginable speed. When this happens, the eruption does not build a cone. It empties a chamber. The ground collapses inward, forming a vast depression called a caldera. This is why supervolcanoes often leave behind wide basins rather than peaks. The land caves in after releasing what it has held for so long. But you do not rush to that moment yet. You stay with the waiting. Supervolcanoes may erupt only once every several 100,000 years. Some wait millions. During this time, life above adapts, flourishes, forgets. Entire species rise and fall while the system below remains incomplete, still gathering, still holding. This patience is what makes them powerful. The scale of stored energy is enormous. When released, ash can blanket continents. Sunlight dims. Temperatures drop. Rain patterns shift. The effects are global, not local. These eruptions can reshape climate itself, altering ecosystems far from the source. And yet, even this is part of Earth's balance. Supervolcanoes are rare. They are exceptions, not habits. The planet does not rely on them often, but when they occur, they act like a reset, clearing landscapes, redistributing nutrients, changing evolutionary paths. Still, you sense how quiet they remain before anything happens. Scientists today study these systems carefully, reading subtle signs. Ground uplift, seismic murmurs, gas emissions. These signals are not warnings of imminent disaster, but evidence of ongoing life beneath the crust. Movement does not mean eruption. Most supervolcanoes spend their existence adjusting without ever releasing fully. The Earth prefers containment. Pressure builds, relaxes, shifts, and redistributes. Magma cools, crystallizes, sinks. New magma arrives. The system breathes, slowly, unevenly, but persistently. Even massive chambers can solidify without erupting, leaving behind frozen reminders of what might have been. In this way, supervolcanoes are stories of restraint as much as power. They remind you that scale does not demand action. Energy can exist quietly, held within boundaries for longer than imagination allows. The planet trusts its structures, its thickness, its strength. As you rest, this knowledge feels strangely comforting. The Earth is not volatile without reason. It is deliberate, layered, careful. Even its most dramatic events are born from patience, not impulse. You lie above systems older than fear, and as your thoughts slow, you may begin to wonder where such immense systems exist today, hidden beneath familiar landscapes, remembered not by myth, but by stone. Places where the land itself holds ancient memory, waiting to be noticed again. You imagine a wide landscape, peaceful and open. Rolling meadows stretch beneath a slow sky. Steam rises gently from the ground, drifting upward like breath on a cold morning. Rivers curve through valleys, patient and clear. Bison move in unhurried lines. Everything here feels ancient, settled, almost timeless. This is Yellowstone as you know it. From the surface, there is nothing alarming. No jagged peaks announcing danger. No towering volcano demanding attention. The land feels calm enough to nap upon, calm enough to forget. And that forgetting is understandable because Yellowstone does not look like a volcano at all. But beneath this familiar beauty, the Earth remembers something else. Far below your imagined footsteps lies one of the largest volcanic systems on the planet. Not a mountain, but a vast, complex network of heat, magma, and pressure stretching deep into the crust. This system has erupted before, not once, but many times, leaving behind clues so subtle that only careful listening reveals them. Yellowstone's memory is written in layers. Hundreds of thousands of years ago, the land you picture did not exist in this form. Where forests now stand, ash once fell thick and heavy. Where rivers flow calmly, fire once surged upward, emptying enormous magma chambers and collapsing the ground above them. These eruptions were not brief spectacles. They were planetary events. The largest of them sent ash across much of North America. Fine particles drifted thousands of miles, settling into lakes, plains, and oceans far away. The sky darkened. Temperatures dipped. Seasons shifted. The Earth adjusted, slowly and unevenly, to a sudden change in balance. And then, after the fire, silence returned. Over time, the land cooled. Rain softened the ash. Plants returned. Animals followed. The scars were buried beneath new layers of soil and life. The surface healed so thoroughly that, eventually, it no longer looked like a wound at all. This is how Yellowstone hides its past. The ground beneath the park is not flat because nothing happened there. It is flat because something immense already did. The wide basin, the gentle slopes, the absence of a central peak. These are the fingerprints of collapse, not calm. The caldera formed when the ground fell inward after massive eruptions emptied the chamber below. What remains is not emptiness, but a system still warm, still alive, still adjusting. Heat rises through cracks, warming groundwater, feeding geysers and hot springs. Every steaming pool is a reminder. Geysers erupt not because Yellowstone is dangerous, but because it is active. Water seeps downward, meets heat, builds pressure, and escapes. These eruptions are small, rhythmic, predictable. They release energy gently, like sighs from the Earth's surface. They are not warnings. They are evidence. Scientists listen to Yellowstone closely. They measure ground movement, seismic murmurs, gas emissions. They read ash layers preserved far from the park, tracing their chemistry back to this place. Each layer is a timestamp, marking when the Earth released more energy than usual. What they find is not a ticking clock. Yellowstone does not build toward eruption in a straight line. Its magma chambers rise and fall in activity. Some regions cool and solidify while others warm. Pressure redistributes. The system breathes unevenly, sometimes expanding, sometimes relaxing. This movement can lift the ground by inches over years, then let it settle again. To the untrained eye, this might feel unsettling. But to the planet, it is normal. Adjustment is safer than stillness. The danger lies not in motion, but in misunderstanding it. Human memory is short. Civilizations rise and fall in moments compared to volcanic timescales. Yellowstone's last supereruption occurred long before recorded history. There are no stories passed down, no myths describing ash-filled skies over this land. Without memory, fear fades, but so does awareness. The Earth, however, does not forget. Ash layers remain preserved far from their source, compressed into stone. Crystals within them record temperature and pressure. Gas bubbles trap ancient air. These are memories written in matter, waiting to be read. You begin to sense how the planet keeps its own archive. Yellowstone's past does not mean its future is imminent. Supereruptions are extraordinarily rare. The system today shows no signs of building toward such an event. But understanding its history matters not because of fear, but because it teaches patience. Teaches humility. The land beneath you is older than human concern. It operates on scales that make urgency meaningless. When change comes, it comes because conditions align, not because time runs out. In this way, Yellowstone becomes a lesson in listening. The geysers speak in rhythm. Earthquakes murmur softly beneath the surface. Heat flows upward in measured amounts. Nothing shouts. Nothing rushes. The system releases energy just enough to remain stable. This balance has allowed life above to thrive. Forests grow because minerals enrich the soil. Rivers flow along paths shaped by ancient collapse. Animals migrate across land born from fire and cooled by centuries of rain. Even beauty here is a consequence of upheaval long past. You rest with this realization. The most dramatic forces on Earth do not announce themselves loudly. They wait, embedded in ordinary places. They teach that calm landscapes can hold powerful histories, and that peace does not require forgetfulness. As your thoughts slow, you feel the comfort of understanding. Knowing does not make the land less beautiful. It makes it deeper, layered, alive with meaning. And as you drift toward rest, you may begin to wonder how ash from places like this once traveled far beyond their origin. How tiny fragments of stone could cross oceans and skies, touching every horizon, binding distant worlds into one shared atmosphere. You picture the moment after a great eruption, not as noise or flame, but as quiet spreading outward. The violence has already passed. What remains is movement so gentle it feels harmless at first. Fine ash rises high into the atmosphere, lighter than sand, lighter than rain, carried upward by heat and wind until gravity loosens its hold. The sky becomes crowded with dust. These particles are small, almost delicate, ground-down fragments of rock and glass, shaped by pressure and heat deep underground. Individually, they seem insignificant. Together, they form a veil that stretches farther than any cloud, farther than sight, farther than memory. You imagine ash drifting over mountains, then over plains, then over oceans. It does not hurry. It does not fall all at once. It travels on currents that wrap around the planet, riding winds that never stop moving. Day by day, the ash spreads, thinning but never disappearing. This is how one place reaches everywhere. Sunlight filters through the ash-filled sky and changes character. It grows softer, dimmer, less direct. Days feel muted, as if the world has been gently turned down. Shadows blur. Colors fade slightly. The sun still rises, still sets, but its warmth arrives weakened. The planet begins to cool. Not dramatically at first, just enough to be noticed by leaves, by plankton, by the slow chemistry of clouds. Seasons shift subtly. Summers hesitate. Winters linger longer than expected. Ice holds on where it once retreated. Rain patterns drift away from familiarity. All of this happens without sound. Ash does not fall like rain. It settles. It coats surfaces quietly, collecting on water, on soil, on living things. In lakes and oceans, it sinks slowly, becoming part of sediments that will one day harden into rock. On land, it blankets fields and forests, sometimes enriching the soil, sometimes suffocating what grows there. The sky has joined the Earth's work. Volcanic ash does more than block sunlight. It carries sulfur gases that react high in the atmosphere, forming tiny droplets that reflect solar energy back into space. These aerosols spread globally, extending the cooling effect far beyond the eruption site. The planet exhales and the temperature responds. This cooling does not last forever. Years pass, decades sometimes. Eventually, particles settle. Gases break down. Sunlight regains strength. But during the time ash remains aloft, life adjusts. Plants grow more slowly. Some fail. Others wait. Animals migrate or alter their patterns. Oceans respond with shifts in currents and productivity. Food chains thin, then rearrange. Survival favors flexibility over strength. You sense how fragile balance can be. Yet even here there is no malice. The planet does not intend hardship. It responds mechanically, predictably to changes in energy flow. Less sunlight means less heat. Less heat reshapes climate. The system follows physics, not emotion. Ash becomes a global messenger. Layers of it settle in distant places, far from volcanoes. Scientists will one day find these layers in ice cores, lake beds, and ocean sediments. They will match their chemistry to specific eruptions, tracing the reach of ancient events across continents. These thin gray lines become timestamps. You imagine future minds reading them, understanding that a distant eruption once dimmed skies everywhere, that the air itself carried the story, that even isolated places were never truly separate. The Earth is connected by its atmosphere. When ash circulates globally, it reminds the planet of this unity. A change in one region becomes a shared experience. No border stops the wind. No ocean blocks the sky. The atmosphere wraps the Earth in a continuous envelope, distributing heat, moisture, and particles without regard for distance. This shared sky is fragile. Volcanic cooling events test it, revealing how sensitive climate can be to small changes in energy balance. A few degrees of cooling can alter ecosystems profoundly. A slight dimming of sunlight can shift rainfall patterns enough to reshape landscapes. And yet, life persists. Some species adapt quickly, thriving in cooler conditions. Others retreat or vanish. Extinction and opportunity move together, guided by altered environments. Evolution accelerates under pressure, favoring traits that tolerate uncertainty. Ash does not end life. It redirects it. Over time, as skies clear, warmth returns. Forests regrow. Oceans rebound. New equilibria emerge. The planet absorbs the disruption and continues forward, changed but intact. The ash that once dimmed the sun becomes part of soil, feeding future growth. Nutrients released from volcanic material enrich land that was once barren. What felt destructive becomes foundational. You feel the rhythm of this exchange. The Earth gives and takes without judgment. Cooling follows heating. Darkness follows brightness. Each phase prepares the conditions for the next. Nothing is wasted. Everything circulates. As you rest, this knowledge settles gently. The idea that the sky itself can change, can carry memory, can participate in planetary transformation. That air is not empty space, but an active player in Earth's story. You breathe, and the air feels closer somehow. Every breath you take echoes ancient skies filled with ash, with haze, with altered light. The atmosphere you depend on has endured countless disruptions, adapting and recovering each time. This resilience does not mean invulnerability. It means response. Ash that touches every horizon reminds you that distance is an illusion on a planet wrapped in air. That events unfold globally even when they begin locally. That climate is not fixed, but sensitive, responsive, alive. And as your thoughts drift further into stillness, you may begin to feel the deeper consequences of this cooling. Moments when summers hesitate entirely, when warmth fails to arrive, and the planet must learn how to live through years of cold. You imagine a year when summer does not quite arrive. The days lengthen as expected. The sun climbs higher, yet warmth feels hesitant, diluted, as if something unseen stands between the light and the land. The air remains cool. Morning frost lingers. Leaves unfold more slowly, unsure whether it is safe. This is what volcanic winter feels like. After great eruptions, when ash and sulfur linger in the sky, the planet cools in subtle but persistent ways. Sunlight reaches the surface weakened, scattered, reflected back into space before it can fully warm the ground. The change is not dramatic like a storm. It is quiet, cumulative, and deeply unsettling for life that depends on rhythm. You sense how much living systems rely on timing. Plants expect warmth at certain moments. Seeds wait for signals carried by temperature and light. When those signals fail to arrive, growth stalls. Forests pause mid-breath. Crops thin. Grasses struggle to complete their cycles. What grows does so slowly, conserving energy, uncertain of what comes next. In the oceans, the change is just as profound. Phytoplankton, tiny drifting life that forms the base of marine food webs, depend on sunlight. When light dims, productivity drops. Fewer plankton means fewer fish, fewer whales, fewer birds that rely on the sea. Entire ecosystems feel the loss, not as collapse, but as quiet scarcity. Volcanic winter does not freeze the world solid. It starves it gently. You imagine animals adjusting. Some migrate farther, chasing warmth that never quite appears. Others remain and endure, burning stored energy, growing thinner, breeding less. Predators struggle as prey numbers fall. Competition intensifies. Survival becomes selective. Cold teaches efficiency. Species that require constant abundance falter. Those that can slow down, store resources, or tolerate scarcity persist. Evolution leans toward flexibility. Bodies change. Behaviors shift. Life experiments rapidly, searching for solutions in a cooler world. Even humans, long before recorded history, likely faced these altered skies. Cooler temperatures shortened growing seasons. Food became unpredictable. Groups adapted by sharing, migrating, and refining tools. Social bonds strengthened under pressure. Survival became communal. Volcanic winters shape not just biology, but behavior. Ice expands where it once retreated. Glaciers advance slightly, reflecting more sunlight, reinforcing cooling. Snow lasts longer into the year. Rivers swell later. The entire climate system responds layer by layer to reduced energy. This feedback is gentle but persistent. The planet does not panic. It adjusts. Over years, sometimes decades, ash slowly settles. Sulfur aerosols break apart. The sky clears almost imperceptibly. Light returns in increments. Summers grow warmer again, not suddenly, but cautiously, as if testing whether stability has truly returned. Life responds just as carefully. Plants expand growth year by year. Animals rebuild populations. Oceans recover productivity. New balances emerge, not identical to what existed before, but shaped by the memory of cold. The ecosystem remembers scarcity, carrying its lessons forward. Volcanic winter leaves no monuments. Its traces are subtle: thinner tree rings, shifted pollen layers, altered sediment chemistry. These clues lie buried in ice and stone, waiting for future minds to notice. The cold itself passes quietly, leaving behind changed patterns rather than visible scars. You feel how absence can be powerful. The absence of warmth, the absence of certainty, the absence of abundance. These absences teach restraint. They slow excess. They force systems to rely on efficiency rather than growth. In this way, volcanic winters act as filters, shaping life without destroying it outright. The Earth has endured many such winters. Some followed supereruptions. Others came after smaller events. Each time, the planet cooled, adapted, and recovered. The process was never painless, but it was never permanent either. Cold is not an ending. It is a phase. As you rest with this idea, you notice how even your own body understands it. When energy is scarce, you slow. When warmth fades, you conserve. You rest more deeply. You adapt without thinking. The planet does the same. Volcanic winter reminds you that stability is not constant warmth, but the ability to respond to change. That survival does not require comfort, only adjustment. That life does not need perfect conditions, only possible ones. And as the imagined cold begins to soften, as light slowly strengthens again, you may start to sense what comes after silence. The quiet return of growth, the patience of seeds beneath ash, waiting not for perfection, but for opportunity. The silence after change is different from the silence before it. Feels deeper, heavier, as if the world is listening to itself. You imagine the land after ash has settled and cold has loosened its grip. The sky is clearer now, though not yet bright. Light returns gently, testing the surface, brushing across soil that has been waiting. There is no sudden explosion of green, no triumphant return. Life does not rush back onto the stage. It arrives quietly, almost shyly, as if asking permission. This is how recovery begins. The first signs are invisible. Beneath the surface, microbes stir. Tiny organisms awaken in the soil, feeding on minerals released by volcanic ash. They break down rock into nutrients, slowly, patiently, molecule by molecule. Their work goes unnoticed, yet it prepares everything that follows. Life rebuilds from the smallest scale upward. Seeds lie dormant, some buried by ash, some carried in by wind or water. They do not all sprout at once. They wait for the right balance of warmth and moisture, guided by signals refined over millions of years. A single warm season is not enough. Trust returns gradually. When plants do emerge, they are often hardy ones. Grasses, mosses, and simple flowering plants spread first, stabilizing soil and reducing erosion. Their roots hold the land together, preventing the past from washing away entirely. What was once bare begins to soften. Color returns in whispers. Insects follow the plants. Birds follow the insects. Small animals move cautiously into these recovering spaces, testing the availability of food and shelter. Each arrival changes the environment slightly, creating new opportunities for others. This process is slow by human standards. It is swift by planetary ones. Forests take centuries to mature. Soils take even longer to fully develop. But life does not measure time the way you do. It responds to conditions, not calendars. As long as energy flows again, through sunlight, water, and chemistry, rebuilding continues. There is no memory of trauma here. The planet does not carry fear of what happened before. It does not avoid certain places because they once burned or froze. It simply responds to what is possible now. This lack of memory is not ignorance. It is efficiency. Ash that once blocked sunlight now enriches soil. Minerals released by volcanic rock provide nutrients plants had lacked before. In many places, landscapes touched by eruptions eventually become some of the most fertile on Earth. Destruction rearranges potential. You begin to see how life does not aim to restore what was lost. Create something new instead. Species compositions change. Migration paths shift. Ecosystems reorganize themselves around altered conditions. The result is not a return to the past. It is an evolution forward. In oceans, recovery follows a similar rhythm. As sunlight strengthens, phytoplankton populations rebound. Productivity increases. Fish return. Predators follow. Food webs rebuild, often with different balances than before. Some species never return. Others expand into newly available niches. Extinction leaves space, and space invites innovation. This is not cruelty. It is continuity. Life persists not because it is invincible, but because it is adaptable. It does not resist change. It incorporates it. The very disruptions that threaten survival also create opportunities for diversification. You can feel this patience settling into you. There is no hurry in recovery. No deadline. The Earth does not measure success by speed. It allows systems to stabilize naturally through feedback and adjustment. Growth pauses when resources are limited. Expansion resumes when conditions allow. Rest is part of resilience. Even landscapes bear this lesson. River channels adjust their paths slowly, carving through softened ash and sediment. Hills erode gently. Valleys widen. Over time, what was once sharp becomes rounded. What was unstable becomes grounded. The planet relaxes back into equilibrium. You imagine standing in such a place thousands of years later. It looks peaceful. There are no signs of catastrophe. Trees sway. Water flows. Animals move through the land as if nothing extraordinary ever happened here. And yet, beneath the surface, memory remains. Layers of ash still lie buried below soil. They record what occurred, even if nothing above hints at it. The earth remembers, even when life does not need to. This quiet persistence is what allows renewal. As you rest with this understanding, you realize that resilience is not loud. It does not announce itself. It does not require strength or dominance. It requires time, flexibility, and openness to change. Life after silence is not triumphant. It is gentle, and this gentleness is powerful. The planet has endured mass extinctions, climate shifts, and upheavals far greater than any single event. Each time, life re-emerged, altered but alive. Not because the Earth protects life intentionally, but because the conditions that allow life tend to re-establish themselves. Energy returns. Water circulates. Chemistry continues. You feel comfort in this rhythm. Recovery does not erase loss, but it moves forward without being trapped by it. It accepts that not everything returns, and that what comes next does not need to resemble what came before. As sleep draws nearer, you sense how this patience carries into the future, toward moments when life is not yet complex, not yet widespread, and humanity itself is still young, watching altered skies and learning how survival becomes a shared memory passed from one generation to the next. You imagine the world as humans first begin to notice it, not as explorers, not as rulers, but as observers. Small groups moving through wide landscapes, watching the sky for signs, the ground for food, each other for reassurance. There are no cities yet, no written words, no fixed homes. Life unfolds close to the earth, tuned to its changes. The sky matters deeply here. When ash lingers high above, the light looks different. Days feel dimmer. Cold arrives earlier and leaves later. For early humans, these are not abstract climate shifts. They are immediate questions of survival. Will food grow? Will animals return? Will this place remain livable? Supervolcanoes, though rare, shape these questions profoundly. When massive eruptions occur, they do not just alter landscapes, they test humanity itself. Ash spreads across continents. Temperatures fall. Ecosystems strain. Populations shrink. Some researchers believe certain eruptions brought human numbers dangerously low, reducing them to small, scattered groups. You feel the fragility of that moment. Human survival is not guaranteed here. There are no stockpiles, no global trade, no science to explain what is happening. There is only observation, memory, and response. Groups that notice patterns survive better than those that do not. Those who adapt their movement, diet, and cooperation endure. Migration becomes essential. As regions cool or dry, people move. They follow animals, rivers, and coastlines. Ash-covered land may be abandoned temporarily, then revisited generations later when fertility returns. Knowledge of places becomes layered with time, remembered not just for what they are, but for what they were. This is how landscapes become stories. Supervolcanoes may also shape language. Extreme events demand communication. Warnings, instructions, shared observations, all require symbols and sounds that can be passed along. Memory becomes communal. Survival depends on what is remembered together. Cold nights encourage closeness. When resources are scarce, cooperation becomes more valuable than competition. Food is shared. Skills are taught. Groups that support one another persist. In this way, environmental stress strengthens social bonds. You begin to see how hardship refines humanity. Fire, already central to human life, takes on deeper meaning during colder years. It provides warmth, protection, and a sense of control in an unpredictable world. Sitting together around flames, people share stories, not myths yet, but memories. Accounts of places that failed, places that endured, signs in the sky that preceded change. Supervolcanoes do not create culture alone, but they shape its urgency. Archaeological evidence suggests periods when human tools change rapidly after major climatic disruptions. Diets broaden. Technologies diversify. Humans become more flexible, more experimental. Necessity encourages innovation. Even movement across continents may be influenced by these shifts. Changing climates open and close migration routes. Sea levels drop during colder periods, revealing land bridges. Humans cross into new territories, carrying knowledge shaped by earlier hardship. Ash and cold push humanity outward. And yet, despite these pressures, humans do not vanish. This persistence is remarkable. Other species disappear entirely under similar stress. Humans survive not because they are strongest or fastest, but because they are adaptable and social. They remember, they teach, they adjust expectations. You feel how close this survival comes to uncertainty. A slightly harsher climate, a slightly longer cooling period, a different distribution of resources. Any of these might have altered the path of human history entirely. But survival is not destiny. It is response. Supervolcanoes reveal this clearly. They do not target humanity. They reshape conditions and humanity responds. Some groups fail. Others succeed. Over time, the species as a whole continues. This shared endurance becomes part of human identity, even if the memory of its cause fades. Long after ash settles and skies clear, stories remain, transformed into myths, rituals, and respect for natural forces. The earth becomes something to watch, not conquer. As humans spread, they carry with them an awareness, subtle but persistent, that the planet can change without warning. That stability is temporary. That adaptation is essential. This awareness shapes values. Flexibility over rigidity. Community over isolation. Observation over assumption. Supervolcanoes, in this sense, are teachers without voices. They instruct through consequence, not intention. They remind humanity that survival is not about resisting change, but moving with it. As you rest with this idea, you sense how deeply intertwined human history is with geological history. Humanity does not stand apart from Earth's processes. It emerges within them, shaped by forces far older than thought. And as sleep draws you further inward, you may begin to wonder how we know any of this at all, how silent ash layers, buried for millennia, can still speak, and how modern minds learn to listen to stone, crystals, and time itself. You return to the present slowly, not with a jolt, but with awareness. The eruptions are long past. The skies are clear. Life has moved forward. Yet the earth has not erased its experiences. Instead, it has stored them carefully, pressed into layers beneath your feet, waiting for minds patient enough to listen. This is where science becomes quiet observation. You imagine a scientist kneeling beside a cliff face, running fingers gently across bands of color in exposed rock. Each stripe is a moment, a pause, a release, ash compressed into stone, layered over centuries like pages bound without ink. The earth has written its story not in words, but in matter. Ash layers are timekeepers. When a volcano erupts, its ash spreads widely and settles quickly. This creates a thin, distinct layer that differs chemically from the material above and below it. Once buried, that layer becomes a marker, a line in time that can be recognized thousands of miles from its source. You begin to understand how distance does not erase origin. Scientists compare ash layers found in lakes, ice cores, and ocean sediments, matching their chemical fingerprints. Tiny differences in mineral composition, crystal shape, and trapped gases reveal where the ash came from and when it fell. A single eruption can be identified across continents, its reach traced precisely. Time becomes tangible. Crystals within volcanic ash grow in specific ways depending on temperature and pressure. Some trap radioactive elements that decay at known rates. By measuring these changes, scientists calculate how long it has been since the crystal cooled. This is not guesswork. It is listening to predictable rhythms embedded in atoms. You feel the patience required. Reading Earth's history demands restraint. Data accumulates slowly. Interpretations evolve. Certainty arrives only after patterns repeat across many samples. One layer means little on its own. Many layers together reveal cycles, intervals, and rare extremes. The planet speaks in accumulation. Ice cores drilled from glaciers hold similar stories. Tiny bubbles trapped in ancient ice preserve samples of the atmosphere as it once was. Scientists analyze these bubbles, measuring gas concentrations that reveal temperature, volcanic activity, and even global vegetation patterns. Ash appears here too, frozen in place. Each particle marks a moment when skies darkened and temperatures shifted. Combined with other signals, these traces allow researchers to reconstruct entire climates, year by year, stretching back hundreds of thousands of years. This work changes how time feels. The past is no longer abstract or unreachable. It is measured, layered, and surprisingly precise. Events that once seemed mythic become dated. Intervals between eruptions become clearer. Patterns emerge where chaos once seemed dominant. Supervolcanoes reveal themselves this way. By identifying massive ash layers linked to known calderas, scientists estimate the size, frequency, and impact of ancient eruptions. They see how rarely supereruptions occur, how long systems rest between them, and how the planet recovers afterward. Fear softens into understanding. This knowledge does not predict the future with certainty, but it refines expectations. It replaces imagination with probability. It teaches that the Earth follows physical rules, even in its most dramatic moments. Listening matters more than alarm. Seismographs record faint tremors deep underground. Satellites measure subtle ground movement. Gas sensors detect changes in composition near volcanic systems. These tools extend human senses, allowing scientists to perceive what cannot be felt directly. Still, interpretation remains careful. Movement does not mean eruption. Heat does not mean danger. Most signals indicate adjustment, not escalation. The Earth shifts constantly, redistributing energy without releasing it catastrophically. Understanding grows through patience. Science does not seek reassurance or fear. It seeks clarity. It acknowledges uncertainty honestly, mapping ranges of possibility rather than promises. This humility mirrors the planet itself, which never behaves exactly the same way twice. You sense how different this is from myth. Ancient stories explained eruptions through anger, punishment, or intention. Modern science explains them through pressure, chemistry, and time. Neither approach diminishes wonder. One replaces fear with comprehension. Ash layers become conversations across millennia. They tell of skies darkened and cleared again, of cold years followed by warmth, of life strained and then renewed. These records remind you that the planet has endured far more than the present moment suggests. You breathe with this awareness. The Earth is not hiding its history. It is offering it patiently, for those willing to learn its language. Science becomes an act of listening, not control, of respect, not dominance. As your thoughts slow, you feel comfort in knowing that knowledge itself can be calming. That understanding deep time reduces urgency. That evidence grounds imagination. And as you drift closer to sleep, you may begin to wonder what all this listening means for today, whether the fires beneath familiar ground are still being watched, measured, and understood, quietly, without panic, as the planet continues its long, deliberate breathing. You drift fully back into the present, carrying deep time with you like a quiet weight that does not press, but steadies. The eruptions you have imagined are ancient now. The ash has settled. The cold has passed. Life has adapted again and again. And still, beneath the surface of the modern world, the Earth continues its slow work. Yes, the fire is still there. Beneath plains, forests, cities, and seas, heat moves as it always has. Magma circulates deep below the crust. Pressure builds and relaxes. Energy redistributes itself through rock and time. Supervolcanoes have not vanished. They have simply returned to waiting. This waiting is not ominous. It is the natural state of the planet. You may picture modern humans as standing watch, alert for danger. But what truly exists is something calmer. Observation without urgency. Around the world, scientists monitor volcanic systems quietly, continuously, not because catastrophe is expected, but because understanding matters. Listening has replaced guessing. Sensitive instruments detect faint earthquakes far below ground, movements too small for humans to feel. These tremors are not signs of eruption. They are signs of adjustment, of rock shifting as heat moves and pressure finds new balance. Satellites orbit overhead, measuring changes in the shape of the land. A rise of a few centimeters over years tells a story. A slow settling tells another. None of it demands panic. All of it provides insight. You begin to sense the difference between awareness and fear. In places like Yellowstone, the land rises and falls gently over time. Geysers change rhythm. Hot springs shift location. Gas emissions fluctuate. To an untrained eye, these changes might feel unsettling. To science, they are expected. A living system moves. Supervolcanoes today are not building toward eruption in silence while humanity looks away. They are being observed constantly, their behaviors compared to what is known from the past. The record written in ash allows scientists to place present signals in context. Context brings calm. The data shows that supereruptions are extraordinarily rare. The intervals between them are vast. Even systems that appear active are far more likely to cool, crystallize, or release energy gradually than erupt catastrophically. The Earth prefers moderation. You realize that the image of a ticking clock beneath the planet is a human invention. Geological systems do not count down. They respond to conditions. Pressure accumulates, but it also dissipates. Magma cools. Chambers change shape. Possibility exists without inevitability. This understanding is deeply comforting. It allows you to see the planet not as a threat, but as a process. A system governed by physics, not intention. A body managing its internal energy with remarkable consistency. Knowledge does not eliminate risk, but it removes mystery, and mystery is often what feeds fear. By knowing how supervolcanoes work, where they exist, and how rarely they erupt, humanity replaces dread with perspective. Monitoring does not mean anticipation of disaster. It means respect for complexity. You sense how different this is from ancient times. Early humans watched the sky without explanation. Eruptions arrived without warning or understanding. Today, while uncertainty remains, it is paired with evidence, models, and shared global knowledge. This is a quiet achievement. Not control over nature, but relationship with it. Humans do not command the fire beneath the earth. They listen to it. They learn its rhythms. They prepare without panic. Preparation itself becomes gentle. Emergency planning exists, but it does not dominate daily life. Supervolcanoes are not looming monsters in modern awareness. They are distant possibilities, placed correctly within immense timescales. The present moment remains safe. You feel how this awareness settles your body. The idea that danger does not hide everywhere. That movement does not equal threat. That change can exist without catastrophe. The Earth is not watching humanity. Humanity is learning to watch the Earth. This shift matters. It reflects maturity, the understanding that stability is dynamic, not static. That peace does not come from stillness, but from balance. That knowledge itself can soothe. As you rest, the planet feels less unpredictable, not because it has changed, but because your understanding has deepened. You trust the slow processes beneath you, just as your body trusts its own quiet functions while you sleep. Your heart beats, your lungs breathe, the earth moves. None of these require conscious attention to continue. And as sleep draws closer, you begin to sense the final perspective forming. Not one of fear or vigilance, but of continuity. The realization that even the most dramatic forces on Earth do not end the story. They reshape it. And in that reshaping lies the planet's deepest truth. It does not break. It resets, adapts, and continues, breathing forward into whatever comes next. You rest with everything you have learned settling softly around you. The fire beneath the planet, the ash in the sky, the cold that followed, the life that returned. None of it feels urgent now. None of it feels threatening. Instead, it feels woven together, part of a pattern older than fear, older than thought. You begin to sense the earth not as something that breaks, but as something that resets. When humans speak of catastrophe, the word often implies an ending, a final moment, collapse beyond repair. But the planet does not experience change this way. For Earth, even the most dramatic events are transitions, shifts from one state to another, rearrangements of energy and matter. Nothing truly stops. It only changes form. A supervolcano empties its chamber, and the land collapses inward. What looks like destruction becomes a basin. What feels like loss becomes space. Over time, water fills the depression. Life follows. Meadows grow. Rivers carve new paths. A place once defined by eruption becomes known for calm. The planet does not mourn what was there before. It does not cling to past arrangements. It does not attempt to restore a previous version of itself. It simply continues, using what remains to build what comes next. This is not optimism. It is process. Fire resets chemistry. Ash redistributes nutrients. Cold reshapes ecosystems. Silence allows recovery. Each phase prepares the conditions for the next. You begin to understand that stability on Earth has never meant permanence. Mountains rise and erode. Oceans open and close. Climates drift. Species appear and vanish. Yet through all of this, the planet remains remarkably consistent in one way: it keeps going. Life is not guaranteed in any specific form, but life itself persists. Even mass extinctions, which sound final, are followed by periods of rapid diversification. Empty niches invite innovation. New forms emerge. What survives is not what was strongest before, but what fits the new conditions best. Adaptation is the planet's language. You feel how this perspective softens fear. The idea that even immense change does not signal the end of everything. That endings on Earth are almost always beginnings wearing unfamiliar shapes. This does not mean loss is meaningless. Extinctions are real. Ecosystems vanish. Unique forms disappear forever. The planet does not preserve every story. But it does not stall because of this. It absorbs loss into the larger flow of time, allowing continuity to outweigh permanence. Continuity is enough. You notice how this mirrors your own body. Cells die and are replaced. Tissues renew. Systems adapt to stress and heal afterward. You are not the same organism you were years ago, yet you remain yourself. The Earth functions the same way. It is not a static object. It is a process unfolding across immense time. Its identity lies not in specific landscapes or species, but in its ability to cycle energy, support chemistry, and allow complexity to emerge. Fire is part of that ability. So is silence. Without volcanic heat, the planet would cool and stiffen. Without periods of quiet, it would never stabilize. Balance arises not from eliminating extremes, but from moving through them. You realize how misleading the idea of a perfect Earth is. There has never been a golden age that lasted. There have only been phases: warmer, cooler, wetter, drier, each producing its own forms of life. The planet does not strive for perfection. It allows possibility. This understanding invites humility. Human history occupies a thin layer at the very top of Earth's timeline. The events that feel enormous to you are fleeting in geological terms. Yet they still matter, because you experience them within human scales of time and meaning. The planet holds both truths at once. It accommodates short lives and deep time simultaneously. It allows civilizations to rise and fall without losing its own continuity. It absorbs impact without retaining fear. You sense how this perspective can bring peace. Knowing that Earth does not end easily does not remove responsibility. It deepens it. It reminds you that while the planet will continue, the specific conditions that support familiar life are not guaranteed forever. Resetting is not gentle for everyone, but the larger pattern remains steady. Energy flows, matter cycles, the system adjusts. The planet breathes through fire, ash, cold, and renewal over and over again. Still breathing, still becoming. As sleep approaches, the Earth feels less like a place and more like a rhythm. A slow, enduring pulse beneath everything you know. You are part of that rhythm, temporarily shaped by it, supported by it. Your rest mirrors the planet's own cycles. Activity gives way to stillness. Awareness softens. Systems continue working quietly in the background. Nothing ends. It simply transitions. You do not need to watch the fire forever. You do not need to listen for ash in the sky. The planet knows how to continue without constant attention. And as you drift fully into rest, held by ground that has endured unimaginable change and remained itself, you carry one final, calming truth with you. The earth does not rush toward endings. It moves patiently through beginnings, again and again, breathing forward into time.